Alright, so turn to a clean set of pages. The left side will be page 49. That's normally a review and a reflect, but I'm not going to worry about that for the video. You can just leave that page blank. And then when you turn over, you should be on page 50. And this is section 11.6 on solving radical equations. Well, I've already done the work on separate paper, so I'm just going to kind of walk you through each problem and just pause the video as you need to write things down if I go too fast or if you need to watch something again. So I'm going to switch over here. Again, section 11.6 on solving radical equations. So there's 4 steps to the process. Step 1 is to isolate the radical. You want to make sure that whatever's under the radical is by itself and it equals whatever else is there. Step 2 is to raise both sides to the root's power. If it's a square root, you'll square both sides. If it's a cube root, you'll cube both sides. Fourth root, to the fourth power, whatever it is, whatever the root is, you raise both sides to that power. Then you solve for x. Sometimes this is quadratic, and it will bring back our factoring skills from chapter 9 and 10. Sometimes it's linear, and you just solve for x. And then from there, step 4 is very important. You need to plug in your x to verify or check your answer. This step is not optional. It's always a good idea to check your answers in math, but for this section you have to check your answers because not always will they both work. Sometimes one will work or the other one will work, or neither of them will work or both of them will work. You don't know until you verify or check your answers. Alright, so for example 1, if you have, let me write the original problem. If you have the square root of 2x minus 3 equals 9. Square root of 2x minus 3 equals 9. The first thing you want to make sure is that the radical is isolated. So if you look, everything that's under the square root is by itself and it equals everything else. There's nothing else around the radical. Once that's the case, you're going to undo the radical. So you put parentheses around both sides. It's a square root, so we're going to square both sides. What that does is it undoes the radical. So squaring and square rooting undo each other, just like multiplication and division undo each other, just like adding and subtracting undo each other. So on the left side, the only thing that happens is that whatever was under the radical is just there, no more radical. On the right, you actually square it and you get 81. So you have 2x minus 3 equals 81, and your job from there is just to solve for x. So we add 3 to both sides, you get 2x equals 84, then you divide by 2, and you get an answer, x equals 42. Again, pause the video if you need to, just jot those steps down. Once you have your answer, you have to go back and check. So from there, I'm going to plug in 42 where I saw x in the original problem. So 2 times 42 minus 3 equals 9. 2 times 42 is 84. Minus 3 equals 9. That's the square root of 81 equals 9. We know that that's true, so 42 is a valid answer. Alright, example 2. If you have the square root of 3x minus 5 equals 7. Go ahead and pause the video. Try example 2 on your own using example 1 to guide you. The square root of 3x minus 5 equals 7. Pause the video, try example 2, then play the video to see the solution. Alright, so you make sure the radical is isolated. Once it's isolated, you can square both sides. Squaring the radical cancels it, so you're left with 3x minus 5 equals 49. From there, add 5, divide by 3, and you should get x equals 18. Once you have your answer, we're going to check. Plug in 18 where you see x, work it out, and make sure that whatever you get is a valid solution. So those are linear, nice and simple. Let's look at this next example. If I have the square root of 3x equals negative 6, we have to be careful anytime it equals a negative. Anytime you square root something, or fourth root or sixth root, we know that the answer is supposed to be positive. So if we get a negative answer, it's not possible. So anytime you're trying to square root something and get a negative result, it's no solution. If that was a cube root, it would be okay, but because it's a square root, we know that that won't work. Let's look at this example. If I have, make sure you guys can see that. If I have the square root of 5x plus 10 equals 0, the first thing we need to do is move that 10. Notice that the 5x is under the radical, the 10 is not. So the first thing we need to do is move that 10 to the other side. Once we do that, we get the square root of 5x is equal to negative 10, which again is not possible. So if I try to take the square root of something, I cannot get a negative result. So there's another example of no solution. Alright, let's try another one. This is example 5. If I have the square root of negative 10x minus 1 and then plus 3x equals 0. The square root of negative 10x minus 1 plus 3x equals 0. Well, I've already worked it out, so I'm just going to kind of walk you through my work. First thing you want to do is notice that the radical is not isolated. You've got this plus 3x kind of floating out there. So you want to move that 3x to the other side. That's going to give us the square root of negative 10x minus 1 equals negative 3x. You're okay, even though it's a negative 3, it's being multiplied times x, so we don't know what's going to happen yet. From there, you'll undo the radical by squaring both sides. So when you square a radical, it cancels out and you're just left with what's underneath it. Over here, negative 3x squared is negative 3x times negative 3x, which is 9x squared. So you should have negative 10x minus 1, what's under the radical, equals negative 3x times negative 3x, which is positive 9x squared. From there, we have x squared and x, so we have a quadratic situation. That means we need to move everything to one side and set the equation equal to 0. That should give you 0 equals 9x squared plus 10x plus 1, which means we need to factor. So I'm going to go through the AC method of factoring, factoring. I should get down to 0 equals the factored form 9x plus 1 and then x plus 1. And we solve just like we did in chapter 10 for both. So we have x equals negative 1/9 and x equals negative 1. Now we don't know if they're both valid answers yet. We have to check. So down here I've checked both of them. I'll just show you everything here. I'm going to plug in negative 1 first. So this is x equals negative 1. If I plug in negative 1 and work it out, I see that it's a valid answer. Negative 1/9 is a little bit harder to plug in. Now I worked it out by hand, but you might want to use your calculator. Let me show you. Your calculator can handle plugging in negative 1/9. If you do the square root of negative 10 times, times negative 1/9, and then minus 1, and then plus 3 times negative 1/9. I like to put it in parentheses for fractions. So I'm just plugging it in, and it should give me 0. So you can type it all in the calculator, or you can see my work that I've worked it out using fractions, and I still get 0. Either way, they both work, so therefore they are both valid answers. All right, let me give you one of those to try. Again, if I'm going too fast, just pause and go back. Go ahead and try example 6 on your own. Pause the video and try it. Here's the original problem. The square root of 16x minus 3 under the radical, not under the radical, minus 4x, and then equals 0. Pause the video, try it, make sure you go back and check. Here we're going to add 4x to both sides to move it over. That's going to give you the square root of 16x minus 3 equals 4x. Then we're going to square both sides. That's going to give me 16x minus 3, which is the part under the radical, equals 4x squared, remember, is 4x times 4x, which is 16x squared. As soon as you see the x squared, you have a quadratic situation. So we need to move everything to one side and isolate. So we get 16x squared minus 16x plus 3. That means we need to factor. So there's the factoring, factoring, factoring down to 2 back-to-back binomials. Then you will solve for x, solve for x. Remember, set them both equal to 0 to get your x values. And then we need to check both of them. And again, I worked them out manually with fractions. You can also use your calculator. So you're going to plug in 1/4, work it out, work it out, work it out, make sure it works. Plug in 3/4, work it out, make sure it works. And if they both work, they are both valid solutions. All right. Let's look at a few more. So example 7 here, a little bit different. Example 7, we have the square root of 4 minus x equals x minus 2. So this time we have 2 terms on the outside, not under the radical. So when we go to square both sides, over here the square and the square root cancel themselves out, and you get 4 minus x. But over here, x minus 2 squared is actually x minus 2 times x minus 2. And you actually need to FOIL that out and work it out. You should get x squared minus 2x again, plus 4, which simplifies to x squared minus 4x plus 4. So if you ever have 2 terms and you have to square them, don't be lazy. Don't just square the first one, square the second one, because then you'll miss that middle term. You need that middle term when you FOIL. So just be careful there. A lot of students get lazy and they just square x and square negative 2, and they miss those middle terms, which throws off all your work. So let me switch back over here. So we FOILed it out. We get 4 minus x equals x squared minus 4x plus 4. Move everything to one side because it's quadratic. You should get 0 equals x squared minus 3x plus 0. Because it's plus 0, you really just have x squared minus 3x, which means we don't really need to factor, we just need a GCF. So if we take out a GCF of x, then you're left with x and x minus 3. So you still have 2 answers. The first one is that x equals 0, and the second one is that x equals 3. So when we go to check, if I plug in 0, it doesn't work out. If I plug in 3, it works out. So the only answer you would put in MyMathLab is 3. 0 is not a valid answer, so you wouldn't even put it in MyMathLab. Alright, I'm going to give you one of those to try. Example 8. I'm sorry, I'm switching back and forth. So example 8, try this one on your own. We have the square root 16 plus x equals x plus 4. Go ahead and pause the video. Try to work that one out all the way and check your answer when you're done. Here again, when we go to FOIL, when we square both sides in FOIL, we actually have to work that out. That should give you 16 plus x equals x squared plus 8x plus 16. Move everything to one side. Then you again get 0 for your constant. So you really just have x squared plus 7x. Then you GCF out the x, and again you get two answers, 0 and -7. When you go to check them, when you plug in 0, it works out just fine. When you plug in -7, it does not work out. So -7 is no good. You wouldn't even put it in the computer, and your only answer would be 0. Alright, so hopefully you're getting the hang of this. Let's try a couple more. Example 9 is, let's see, the square root of 40 minus x equals x plus 2. If you want to pause the video and try that one, you can. If not, you can follow along with me. When you go to square both sides, when you go to square both sides, you have to FOIL. So you're going to get 40 minus x equals x squared plus 4x plus 4. Move everything to one side because it's quadratic. You should get, 0 equals x squared plus 5x minus 36. Then we'll factor. This one's a little bit easier to factor because the leading coefficient is 1. So it factors into x plus 9 and x minus 4. Then you get your two answers, -9 and +4. Over here I checked -9. It did not work. I checked 4 and it works. So -9 is no good. +4 is your only answer. Alright, if you're getting the hang of this, you're good. If you'd like to try one more, let me give you one more to try. Let's see here. Example 10. This will be our last one. Let's see, example 10, the square root of 53 minus x equals x plus 3. Again, I would pause the video, try this all the way to completion, check your answers, and then play the video back to see how you did. Alright, here's example 10. Make sure you can see it. You go ahead and square both sides. Again, when you square, you'll have to FOIL. You should get 53 minus x equals x squared plus 6x plus 9. Move everything to one side because it's quadratic. You should end up with 0 equals x squared plus 7x minus 44. Then we need to factor. Because the leading coefficient is 1, it's a little bit easier to factor into x plus 11 and x minus 4. From there, you should get x equals -11 and x equals 4. And then when you go to check, -11 does not work, and +4 works. And it's not that x is negative. It doesn't really matter if x is negative. It matters what happens when you plug it back in. So you can't just guess which one's going to work. You've got to actually plug them both in and see which one works. Sometimes they both work. Sometimes only one of them works. There are very rare occasions where neither of them works. But you've got to check just to make sure. Alright, so that is it. If you need to play the video again, you can, or pause and go back, whatever you need to do. Finish your Chapter 11 homework, and then you have your Chapter 11 exam.